Hey, this is Math 7, Unit 6, Lesson 7, Reasoning about Solving Equations, Part 1. Alright, and so again, the first one is a little bit of a cool down, a review of what you did in class today. So solve this equation, it says, and if you get stuck, try using a diagram. So you have some fractions there to work with, but I think you can figure those things out just fine. Moving over here, we have explain how the parts of the balanced hanger compare to the parts of its equation. And so when we look here at this first one, I'll look at this one together first of all, we see we have 3x plus 1 equals 10. And we can definitely see how, in terms of the balancing acts going on, we can say this part is equal to this part. And that's our 10. That's pretty obvious there. We can see the value of the 1, which is the diamond shape right there, which is the 1. And then in our diagram, we see we have three groups of x. We have group 1, group 2, group 3. And so we have three groups of x here, which is represented by the 3x in our equation right there. So we can see those parts, and when we combine the 3x and the 1, those combine together to give us a value of 10. And that's what we see happening there in number 2. So you want to be able to kind of write that out or draw it some way to explain it to your teacher for what that looks like. And then do the same type of thing for this part over here. In number 3, it says here is a hanger diagram. Write an equation to represent the hanger diagram and explain each step on how to solve it. So for this equation here, we can see that we have 1, 2, 3, 4 x's, or 4 groups of an x, and then we're going to add to that the 13. Add to the 13, and then we'll set the entire thing equal to what's over here, which is the 25. Our first step is going to be to do what? First step is going to be subtract 13 from both sides. So step 1, subtract 13 from both sides. That's our first step. So that gets us here with a 0, which means we're left with a 4x equals, in this case here, 12. Step 2, we're going to divide both sides by 4. We divide both sides by 4, leaving us with x equals 2. And then we get our solution on the third step for x equals 2. So those are our steps right there that we have to go through to find out what the value of x is going to be. Alright? Yeah. Okay. So, x is 2. No. 3. I'm sorry. X is 3. Like 3, 2 didn't sound right. I wrote 3, then I wrote 2, because I had to step 3. X is equal to 3. This is right. And the reason I paused there is I was thinking of the picture, thinking 2 is not going to work. 2, 4, 6, 8 plus 3, 13 is 21. So nope. Has to be 3, 3, 3, and 3 for 12, and 13 make 25. Alright, there's another diagram here for number 4. I'll let you solve that one on your own because it's very similar to number 3. You should be okay on that one. And then finally, not finally, but next we'll look at number 5. And it says find the unknown value using the bar model and the hanger diagram. So this one is the hanger and this is the bar, and then explain your process. So you're going to do some writing here to explain what you did each time. So for the hanger model, we set it equal to 2 groups of D plus the 4 is going to be equal to 20. And we'll solve from there. We'll subtract 4 from both sides. So that 2D equals 16. We'll divide both sides by 2 in order to get the D by itself. And D is going to be equal to, D is equal to 8. Okay, so that's that one right there. Alright, and then over here we have 2 groups of a D plus 4. And so we have 2D plus 4 equals 20. And again, we'll do the same steps there. So there's really not a difference here. It's the same idea. This one is just in a hanger and that's in a bar model, but they do both use the same process to find a solution. Let's look at the back side. On the back side, we began with some review problems here, and so we can see that we are having some subtraction here, negative 4.3 minus 6.2. And so whenever we have a subtraction problem, we usually want to think about that as addition. We like addition better, and that's the same as adding a negative 6.2. At this point, we see that our signs are the same, so we'll find the sum, meaning add these up, but keep the sign the same. You should end up with a negative value there. Over here, we're going to add those up. You might want to combine the ones with the same sign first, and then remove the 0.4. And over here, we're dividing a negative by a positive, which should result in a negative answer. But you can solve those. Those are good review problems for you. Number 9, it says a salesperson's weekly pay rate is $895. She receives a 25% raise. A raise is going to be an increase. What's the new pay raise? Okay, so a couple ways of thinking about this. Okay, we could find out what 25% of that value is going to be and then add it back into it. Meaning we could do 25% of 895 equals whatever it's going to be. Let's call it x. And then we would do x plus 895, and that's going to be the answer we want because we're adding the 25% back to that one. That would work just fine. But the other thing we can do is we can recognize that 100% of 895 is 895, right? So really what I'm doing is I'm doing 100% plus 25% to see what that total new pay rate is going to be. So I actually want to find out 125% of 895, and that'll give me the direct answer because 125 I'm adding 125, whereas here I'm adding 25%, which is this one, to 100 because this is 100% and this will be the 25%. So it's the same thing, but I can just do it directly. So 125% as a decimal is 1.25. I multiply that by 895. And when you multiply that out, you end up with 1,118.75. So what's your new weekly pay? The new weekly pay is going to be $1,118.75 if I did my multiplication right. Number 10, it's a magic square again. Again, we're going to do this so that everything diagonally, horizontally adds up the same. We have 2 plus a minus 5, we're at minus 3, plus 0 is minus 3. So again, that's going this way is minus 3. And we want to be able to do the same thing vertically. So then start with this one next. So minus 5, minus 1, we're at minus 6. Got to get to minus 3. So negative 6 plus 3 is going to get you to minus 3. So now I have a number there. I could then work on a diagonal, and we should be okay. So continue to solve that one, all right? And finally the last one, looking at the perimeter of the figure below. This perimeter is a composite shape. We have a rectangle here, and we have a semicircle and a semicircle, which join together make a full circle with a diameter of 12. So I know that this length is 20, which means this length is also 20. So those two combine, 20 plus 20, I know I have a length, a perimeter of 40 so far, and now I need to find the distance around this circle. The distance around a circle is found by finding the circumference, right? And the circumference is found by doing pi times the diameter. In our case here, the diameter is 12, so we have 12 pi. So basically, when we add this and that together, that's going to be the perimeter. The question is going to be, what did your teacher want you to do with pi? I don't know. So if you multiply 12 by 3.14, which is an approximation of pi, 4 times 2 is 8, 2 times 1 is 2, 2 times 3 is 6, put a 0 there. We have 4, 1, and 3. So we add this up. We have 2 behind the decimal, so we'll go 1, 2. So we're going to add 40 and 37.68 together to show that the perimeter is 77.68 feet combined. So that's the circumference around the circle, the round parts, and added to the straightaways there. That's it for today. Have a great day, and we will see you next time.